sort of in the chemistry area a bit further on from what John just talked about, because I started out doing tutorials now, and it's now grown into a very much of a full-fledged website. And today, and the URL is right there, bestchoice.net.nz, and it is open access. We do ask people to register though, because we found that if you can look at demo mode and see what's there, get some ideas of what we can do, but we thrive on registrations because we actually thrive on you and all your students becoming part of our statistics. And I'll just go to, actually I'll just have to go to my place. We've got lots of things. Okay, so the presentation I'm just going to do is available on demo mode. And if I remember rightly, is this the university presentation that I'm giving? Because I'm giving one after. I hope I've got the right one first. We'll do the university one, okay? I'm giving it. This is all about the interface, and I'm doing one on university stuff and one on high school stuff. Now, Best Choice, as I've already explained, is open access, but the focus is on interactive learning. And this man, who's been my partner in crime, has played a very key role, so he gets on the front page. There are three strands of the Best Choice project. One is designing activities, like what you've been doing, to try to foster learning. And this has involved establishing a teaching model, and I had some ideas about what I wanted to do along those lines from work I had done for the DOS system. And then also a big task is creating a system to deliver the content interactively, because we really weren't very satisfied with the existing systems, and we didn't think we could do what we wanted to do. And then once you've got the activities, that's only part of the issue, because you've got to achieve usage. And we found that the best way to achieve usage is to put out customized content for particular target groups. And then once you've got the target groups of RY, make sure you've got good support for both the learners and their teachers. And then finally, the really very, very important part of the thing is to analyze your usage data so that you can actually inform improvements. And that's one thing that the web has over a lot of other teaching methods. The data accumulates, and you don't have to go back and key in, code in stuff. It's just sitting there building up in the background. Now, I just have a couple of slides about the types of question pages and things that we have available, just to give you some idea of the type of thing we do. We've got interactions so that you have a whole lot of different styles of putting in the answers, and those are designed basically so that you are not in a situation of the dog wagging the tail, so you can do it in a way that's pedagogically reasonable for your subject. Now, this is just a simple redox equation, which kids would have to write based on a statement like, if copper metal is immersed in silver, or silver is precipitated and the solution turns blue. And we ask them to write the half equations. Well, I reason that the first thing that they should be able to do, one equation is going to accept electrons, one equation is going to donate electrons, and I think it's actually quite a significant challenge to most kids to figure out whether the copper is involved in this one and the silver in that one, or reverse. So the first thing they have to do is choose the reactants in the electron accepting reaction, and of course that means that they have to realize that silver plus has gone to silver zero. Silver plus, has gone to silver zero. So we'll choose these, and then it's pretty neat to know whether you're right or not. And so if we submit and we find out that we're right, then we say, okay, that's fine, and we'll go on, and then to complete the equation by just adding the electron. And then, of course, the other pair is copper 2 and copper 0, but again, without reading the words carefully, they may not realize in which order they're entered, and then we'll put in the 2. And then, of course, before we combine these to write the entire equation, we have to multiply this by multiply this one by 2, and multiply that one by 1, and then we can do the entire equation down here. Silver plus and copper are the reactants, and copper 2 and silver are the products, and then to fill in the coefficients to balance the equation. And we're doing this pretty much the same way you would actually do this on pen and paper, okay? And you may have noticed at one point there I got an answer wrong and some feedback came up. And so that is one of the big things we make, very intensive use of feedback. Feedback for right answers. I mean, this one, the total charge on products must equal the total charge on reactants as appeared during the equation, where electrons added, and then also feedback for wrong answers. Okay? And if you print this out, it comes out just like a printed page out of a textbook. Okay? So that's one type of question. This is in another area, organic chemistry, where people are always worried about how to teach mechanisms. And we've got, this is just an example of one organic type question where you can drag the arrow and then you choose the next product, then you've got another arrow, and then you choose the next product, and then you've got another arrow, and you can choose the next product, and then the last arrow, and the final product is this, and you get this. Okay? And again, this is pretty much the way you would do it while you were doing it on pen and paper. Of course, if you were doing it on pen and paper, you would draw those structures, but while the student's learning, it's probably challenge enough for them to actually just select what structure arises from that